Welcome to Lesson 11, the moment your NGINX skills go cloud native. For the past 10 lessons, you've been editing nginx.conf on a VM. Today, that same engine moves into Kubernetes, and the configuration surface splits into 4 pieces: the ingress-nginx controller, ingress resources for host and path routing, annotations for per-route tuning, and a ConfigMap for global settings. The binary is identical. Only how you talk to it changes. Let's map those 4 pieces. First, ingress-nginx, the community controller from the Kubernetes SIG, free and the most deployed in the world. NGINX Inc ships a separate commercial one for NGINX Plus, but for this lesson we stay on ingress-nginx. Second, the ingress resource. That's just an NGINX server block expressed as YAML, with hosts, paths, and a TLS secret reference. Third, annotations. Every directive you use to drop into nginx.conf, like proxy, read a timeout, or rate limits, now rides along as a per-ingress annotation. And fourth, the ConfigMap. Global tuning like worker processes and keep-alive timeouts, edited once and reloaded automatically. Different surfaces, same engine. Now let's line up those surfaces side by side. Routing rules that lived in a server block become an ingress resource. The SSL certificate file becomes a secret referenced under TLS. Per location directives move up to annotations on the ingress. Global HTTP block tuning moves into a config map, and that manual NGINX S reload gone. Apply the YAML. The controller reloads for you. File-based and imperative on the left, declarative and GitOps friendly on the right. Same mental model, new packaging. Installation is genuinely a one-liner. Add the ingress-nginx helm repo, then helm install into its own namespace. Here we're setting 3 replicas for HA and enabling the metrics endpoint for Prometheus. On EKS, GKE, or AKS, the service of type load balancer gets a real external IP provisioned automatically. On bare metal, pair it with metal LB or fall back to node port behind your own load balancer. A quick kubectl get pods confirms 3 controllers running, and you've got a public IP ready to receive traffic. With the controller running, per application routing becomes a YAML resource. This ingress declares the shop namespace, selects the NGINX class so our controller picks it up, references a TLS secret holding the cert and key, and defines 2 path rules. /API goes to the API service, everything else falls through to web service. Apply it with kubectl, and the controller rewrites nginx.conf and reloads. No SSH, no manual edits, no service restart. Now, where do you actually put configuration? 2 scopes, 2 surfaces. Anything per application, proxy timeouts, body size limits, rate limiting, even raw NGINX snippets, goes as annotations on the ingress itself, like the proxy read timeout of 300 or the 50 meg body cap shown here. Anything that tunes the controller as a whole, worker processes, keep alive, JSON log escaping, enabling mod security from Lesson 9, lives in the controller's ConfigMap. Rule of thumb: per app to annotations, whole controller to ConfigMap. Same NGINX directives you already know, just relocated into Kubernetes objects. Let's put it all together in one production-grade manifest. This single ingress pulls in 5 concepts from across the series. Cert-manager auto-issues a Let's Encrypt certificate via the cluster issuer annotation and writes it into the API shopcom TLS secret. Proxy read timeout and proxy body size tune the upstream behavior. Limit RPS caps traffic at 100 requests per second. And the mod security plus OWASP core rules annotations switch on the WAF from Lesson 9. Apply this YAML, and within seconds you have TLS, filtering, and rate limiting. The same NGINX directives you've always written, just declared once and reconciled by the controller. Now the honest question, why bother with all this YAML when a single nginx.conf on a VM would do the job? 3 reasons. First, self-healing. Kubernetes replaces failed pods automatically, while a VM hardware failure means you're paged at 3 a.m. Second, GitOps. Your routing lives in Git, reviewed via pull request, deployed by Argo CD or Flux, with rollback as simple as git revert. And third, per namespace ownership. Team A edits, Team A's ingresses, RBAC enforces the boundary, no merge conflicts in a shared config. Above roughly 3 services, the YAML overhead pays for itself. Below that, honestly, VM NGINX is still simpler, and that's fine. So here's your printable cheat sheet, the surface area you actually need on day 1. 3 resources: Ingress for per-app routing and TLS, ConfigMap for global controller tuning, secret for the cert and key pair. Then 4 annotations that map almost one-to-one to directives you already know. Proxy read timeout, proxy body size, the rate limit pair, and configuration snippet as your escape hatch when an annotation doesn't exist yet. Ignore the other 200 annotations until you genuinely need them. These 5 cover roughly 80% of real config work. Theory's done. Time to put hands on a cluster. 3 drills, about 70 minutes total, all on a local kind cluster you can spin up in 90 seconds. Exercise 1. Install ingress-nginx with helm and port forward to it. Exercise 2. Deploy a service, write a minimal ingress YAML, hit it with curl. Exercise 3 is the payoff. Add a proxy read timeout annotation, then exec into the controller pod and grep the generated nginx.conf to watch your annotation become a real directive. That last one is the moment Kubernetes Ingress stops feeling like magic. Before you ship to production, here are 5 mistakes that VM experience simply won't catch. Forgetting ingress class name means your ingress is silently ignored. No error, just nothing. Reaching for configuration snippet to inject raw nginx feels natural, but it bypasses every benefit of declarative config. Editing nginx.conf inside the pod gets overwritten on the next reconcile. Backend services must live in the same namespace as the ingress, and Helm's defaults skip resource limits. Set memory to 1 gig from day 1, or a leak becomes a 30-second outage. And that wraps lesson 11. The takeaway is simple. Same NGINX engine, same routing logic, same tuning instincts. Only the configuration surface changed from imperative files to declarative YAML. Ingress for routes, annotations for per-route tweaks, ConfigMap for globals. In Lesson 12, the graduation, we close the series with honest benchmarking, WRK, AB, and Vegeta, and the discipline of measuring before you tune. See you there.